Lately, the concept of multi-agent systems is gaining traction for their ability to provide checks and balances. We've seen customers already using multi-agent systems for a few different use cases. One use case is to create accurate SQL queries for complex data analyses. Another use case is to ensure companies' marketing content is correct and brand aware. Let's create a multi-agent system where one agent generates content and another evaluates it, using a feedback loop for improvement. The system works like this. User provides a content prompt. An example is, write an article about AI. In generation phase, the generator agent uses OpenAI API to create content. In first iteration, uses just the prompt. In subsequent iterations, includes previous feedback. In evaluation phase, the evaluator agent analyzes the content using set criteria. An example of criteria is in the areas of content clarity, content accuracy, content relevance, and so on. The evaluator agent provides numerical grade on a scale of 1 to 100. The evaluator agent provides detailed feedback to generator agent for improvement if the grade is less than passing score. This feedback loop continues until passing grade or maximum iterations is reached and a final content is published. Let's go over the implementation of this workflow. This program defines a class called Content Generator Agent that utilizes OpenAI's API to generate content based on user input. Here's a breakdown. The content generation method takes 3 arguments. Prompt. This is the starting point for the content generation, a sentence or two describing what you want. Context. This is optional. This provides additional information to guide the generation. Previous feedback. This allows incorporating feedback from prior attempts to improve the content. It constructs a message structure with the user's prompt, context, and feedback. It uses the OpenAI API's chat completions create function to generate content based on the provided information and model. After successful generation, the method returns the created content. In case of errors during communication with OpenAI, it prints an error message and returns an empty string. Overall, this program acts as a wrapper for OpenAI's API, allowing users to easily generate content based on prompts, context, and feedback. This program defines a class called Content Evaluator Agent that utilizes OpenAI's API to evaluate content based on user-defined criteria. Here's a breakdown. The Evaluate Content method handles the core functionality. It takes 2 arguments. Content, the text you want to evaluate. Criteria, a dictionary containing evaluation criteria and their weights. Note that the weights should sum to 1. It constructs a message structure with details about the content and the evaluation criteria. It utilizes the OpenAI API's chat completions create function to get an evaluation based on the provided information and model. After successful communication, it retrieves the evaluation content. The program then parses the returned content to extract a grade and detailed feedback. In case of errors during communication or parsing, it returns a default grade 0 and an error message. Overall, this program acts as an interface for users to get content evaluated by an AI based on specified criteria. This program combines the functionalities of the previous 2 programs, Content Generator Agent and Content Evaluator Agent, to create an iterative content optimization process. The optimized content method is the core functionality. It takes a prompt and a dictionary of evaluation criteria with weights as input. It initializes variables for content, grade, feedback, and iteration count. It starts a loop that continues until the content reaches the passing grade or the maximum iterations are reached. A 1-second delay is added to respect API rate limits. After the loop, the optimization process is declared complete. Final grade, total iterations, and a pass-fail message are displayed based on the target grade. Overall, this program provides a comprehensive system for iteratively generating and evaluating content until it meets predefined quality criteria. The main program has the sample configuration and prompt to generate and optimize the content. This takes the prompt and evaluation criteria as arguments. Change the evaluation criteria and prompt as per your needs. It runs the iterative optimization process and retrieves the final optimized content, final grade, final feedback, and number of iterations used. Install and setup instructions are provided in the README file. A link to the accompanying GitHub repository will be provided in the video description. Ensure that .env file is updated with your OpenAI API key. Also change passing grade or maximum iterations to your needs. Let's run the agent and see it in action. Target grade is set to 92 with maximum of 3 iterations. Prompt for this demo is to write a brief explanation of machine learning for beginners. This starts with content generation process, followed by the evaluation process. The logs show clear iteration boundaries. During iteration 1, the generated content is shown along with the feedback for improvement. The grade in iteration 1 is below the target. So it repeats iteration 2. The content is modified based on the evaluation agent feedback. The content in red font is replaced with the content in the green font as shown. In reviewing the optimization history, the agent has scored higher grade in iteration 1, but the grades dropped in iteration 2 and iteration 3. This means that the agent has not properly updated the content based on the feedback provided. Let's repeat the same scenario again and see how the agent handles this. We have executed the same prompt with same target grade of 92. In iteration 1, the agent received grade 90, but it improved in iteration 2 and achieved the target grade without the need for the third iteration. The final optimized content is printed here. Multi-agent AI systems hold great potential for solving complex real-world problems and are a growing area of research and development. This framework can be extended several other use cases. There is a need for frameworks like Swarm or LangChain when several agents need to work together and achieve goals. Now you know how to build a multi-agent workflow without the need for external frameworks. Hope this video was helpful. Thanks for watching.